Alright, let's take a look at another side-by-side example. Here we've got the fraction 14 tenths, and here we've got this rational expression. And we're going to do both in a very similar way. So, again, even though we could probably do this in our heads, we're going to show the work. 14 factored, one way to break it up would be 2 times 7. And I want to do it that way because I'm seeing that the 10 below, we could break that up into 2 times 5. And in which case we have factors 2 and 2 in the numerator and denominator, which will cancel each other out. And this reduces down to 7/5. Let's see if we can't do the same thing over here. On this rational expression, in the numerator, I see 3n plus 6. And if I go through all my different factoring tricks, the one thing that comes to mind is taking out a common factor. 3n and 6 share a common factor of 3. So if I take out that 3, it leaves me with leftovers of n and 2. So n plus 2. Now, in the denominator, I don't see any common factors, but I do think I can factor this with one of my other methods. Yeah, because if you look here, 6, what multiplies to 6 and adds up to 5 is 3 and 2. So I could split this up into n plus 2 times n plus 3. And now that everything is broken up into factors, I can see that here and here I share a factor of n plus 2 and n plus 2, which I can cross out, which gives me 3 over n plus 3. And so there's my simplified rational expression. Now you might ask the question, well, can't you cross out the 3's? In this case, no, because if you look at this bottom 3, it's n plus 3. We're adding with the 3, so it's not a factor. In order for something to be a factor, you have to be multiplying with it like we're doing here with the parentheses. Because we're adding with that 3, it's not a factor, so it's not the same thing as this 3 up top, and we can't cancel it. So this is our answer here, just like 7/5 was our answer over here.